So we will continue with the place where we had left in the last class. So right now in the unit where we are talking about advanced concepts relating to data analytics, reporting and problem solving. Those are okay. So if you guys remember in the last class we talked about some of the key constructs of those are yeah. Everybody can hear me okay, right? Cool. So in the last class we were talking about some of the basic concepts of relating to center and spread, and that is where we tried looking at mean, median, mode with a different perspective. And so we looked at the concept with a little different perspective that okay, if I'm talking about mean, median, mode, it is just not a method to calculate. It gives you a lot of insight about the data that we are looking at. Yeah. So if you're looking at mean, median, mode, it tells you that okay, what is the central behavior of the data that you're looking at, and how do you interpret something out of it. Yeah, I will show you. And then we touched upon standard deviation a little bit, and we were wanting to kind of decode what is standard deviation, and we looked at some examples. What we'll do is we will, in the class today and tomorrow, we'll look at and we'll do a quick recap of what we learned with respect to standard deviation, and then we'll go from there and talk about the next phase, which is around reporting. And again, our objective would be to decode things and understand things in a simpler, relatable way. Okay? Just give me 30 seconds. So, what's your name?
I'm Datta.
Datta, come over. Be my guest.
Sorry for the
I will close the door because he's the only one in the class. Okay? Alright. Have a seat, brother. And be just careful with the table. It's a little tiny. So if you're moving much, it might flip. So be a little careful if you're moving. Okay. So far, whatever we did, whatever we talked about, that was nothing but elaborate. Okay. So don't worry about anybody who joined in between or a little later has missed anything. So are you sure? So here in the classroom we have one more child. I call you guys kids or child. So your name is Datta. And I'm pretty poor when it comes to memorizing names, okay? So I might mess up with your name a couple of times. It takes me a couple of classes to make sure that I don't go wrong. Okay? Now for you to be aware, you are seeing an iPad right now. This iPad on the stand. This one. This guy here.
Oh, yeah.
It is recording me. What it means is, whatever we do in the class, that is all recorded. Me and the board is getting recorded. So you don't have to worry about taking notes or anything. This video will be there for you to revise later on. So in the class, always focus on learning the concepts, arguing with me, debating about the things. If I give you guys some problem to solve, you will focus on solving those rather than worrying about did I miss something. Okay? That's the thing. That's the reason why I'm recording it. So right now we are in the unit which is around problem solving, data analytics and reporting. Okay. And you have joined the middle of the class, that doesn't mean that we have missed anything because we keep going in loop. Okay. Like any old guy who keeps on repeating things over and over again. That's what I do in the class. So we are on this unit, we'll go to the next unit and we'll keep going in loop so that we always stay focused on learning things, and whatever we learn once, we don't stop. We learn it again, and keep practicing it so that it becomes a part of day-to-day stuff for us. Okay? Alright. So I see that we have pretty much everybody in the class. Yeah. In between, who joined? Yvonne had disconnected and joined back again. So, alright. So now, this is the official start of the class. And in next 1 hour, or 52 minutes to be precise, what we'll do is, we'll talk about certain concepts around data analytics and problem solving. I will talk about the concepts, get everybody's opinion, make sure everybody is clear about it, and then we'll solve few problems and see how we are able to apply the concepts for solving real problems. Alright? So, in the last class we talked about standard deviation. A little bit. We tried solving one problem also, and then we left it there. So, we'll talk about standard deviation one more time, just to make sure that everybody in the class is very, very clear about this concept. And then we'll move on to the things that I had mentioned in the group. So let's first talk about standard deviation. Everybody is clear, right? What is standard deviation?
I don't know.
You don't know about it, okay? Pranit is clear. Biswa, do you remember what did we learn in the last class? Ananya is clear. Yes, Jana.
Do you think we can go over it just like one more time, please?
Yes, we will. See, that's what I take pride in. I teach less things, more number of times. To waste everybody's time, don't worry about it. I will get you guys tired of each and every concept that we learn, okay? Don't worry. So, let's look at some of the basic concepts and then we will go to the mathematical side of it. Let's say I have now a group of numbers 1, 3, 7, 14 and 17. These are the 5 numbers I have. Okay? And then I have 2, 99, 44, 3 and 17. This group has 5 numbers, this group also has 5 numbers. What is the basic observation we have by seeing these two groups of numbers? And guys, if I'm saying something very stupid, bear with me. It's okay. Yeah, tell me like a child. I'll come to you, Pranit. Datta is in his first class, getting ready to get tortured by me. So I'm asking him, what is the basic observation? Don't keep anything presumed in your mind. Just by looking at this number, right? We are all human beings. We make observation by seeing things, right? When you came to the classroom, imagine this classroom was all messed up, a lot of dirt here and there. What would have been your impression? You would make a judgment. Oh no, this is not a hygienic place. Okay? We make observations. So by looking at these numbers, what is the observation you would make? A very simple, normal observation.
I don't really know. I guess the first one, like all of them are odd numbers except 14.
Say that again.
All of them are odd numbers except 14. Yes, that's all I.
Okay. Let's hear Praneet. Yes, Praneet. Tell me what is your observation? Datta, you can try to come to the first row so that you will get the little warm this thing from there and you can see things better. You can begin your book. Yeah, Praneet, go ahead.
The first data set has amount of variance.
Do you want to say it louder?
The first data set has less variance than the second data set.
Exactly. What do you mean by variance? When things are changing, right? See here, 1, 3, 7, 14, 17. Between first and second number, change by 2. Second and third number change by 4. Third and fourth number change by 7. 14 and 17 change by 3. So, it's changing. Assume this is temperature, okay? This kind of change our body can tolerate. It's changing gradually, not changing too much. Look at this range. First number is 2. Then change by 97 to become 99. Then again dip by 55 to come to 44. Again dip by 41. Too much of change, too much of variance, too much of variation. That is what we mean by deviation. The numbers are deviating less here compared to this. Yeah? Jana, Sahib, Riya, Anush, everybody okay? So, that's what the basic thing. I have told this 100 times. I have no shame in saying 101 times. Whenever you see something, don't overburden yourself. Always think simple. Simple things are very nice, trust me. Okay? So, simple observation. Like what Praneet said, Here you have less variation, here you have more variation. Lot of changes. Now, whatever Praneeth said or whatever I am blabbering, it's very subjective in nature. I'm saying this is a lot of variance, less variance, lot of variance. There is some method to the madness. And that is where this concept of standard deviation comes into picture. Okay? So here you have less variance, less deviation between the value, more variance, more deviation within the value, but there is no mathematical tool we have talked about so far. I mean, I have talked about it in the past, but not in this class so far, which gives me a method to quantify it. Standard deviation is a tool that gives us the means or tools or platform or way to give a mathematical definition to it. So now, if without knowing about what is standard deviation, since you guys can see it that here you have less variance, here you have more variance, you will say that here the standard deviation is less, here the standard deviation is more. And that will sound more convincing to people who are more mathematically aligned. They'll say, oh yeah, this guy is making sense. And then the follow-up question is, okay, how much it is? You are saying that this has less standard deviation, it has more standard deviation, but how much it is? That is where the calculation comes into picture. Okay. So record this picture in your mind. Did I put the formula correctly, Pradeep, Ritika, Vishal? Okay. So, Pradeep, go ahead. Yeah, okay, I did. Ritika, are you able to hear me okay, Vita? I know I think you were the last one to join. Okay.
Yeah, I was on mute, so I couldn't hear from my headphones, so I was like...
That's okay. Yeah, no, I'm just checking Vita, that everybody is with me. So, here, this is the formula, and again, I'm not trying to scare you or I'm not trying to impress any of you. This is the means to do it. This formula, if you remember, wonderful. If you don't remember, it's even better. Because I keep on saying that memorizing formula is my weak point, my weakness. For last 35 years, I'm not 35 years, close to 40 years now. It's been my weak point. I have failed miserably when it comes to memorizing formulas. All that I remember is because based on the concept and the practice, whatever I've done. So let's decode this one. What this says in simple English, it says that, okay, everybody knows what is mean, right? Mean, except your teacher being mean. Mean is the way to calculate the average. Yeah. So now let's look at this guy. We'll come back to this formula later. Look at this number, this set of numbers. 1, 3, 7, 14, 17. If I ask you what is the mean, what you will do is, you will add them up and divide by the number of data elements you are dealing with. 1 plus 3, 4 plus 7, 11 plus 14, 25 plus 17, 42. If I made a wrong calculation, ignore it. And as long as you know what we're trying to do, it's fine. It gives me 8.4. I will just round it to 8, okay, for now. I'm assuming that whatever numbers I had, I'll make this 15 now, okay, so that I'm not misleading you guys. So this is 1 plus 3, 4 plus 7, 11 plus 14 is 25 plus 15, 40. Yep. So we got the mean. So once you have the mean, what you do is, you are trying, so what is mean? Mean is like the central behavior of the data that you're looking at. Mean is like the average. So standard deviation says, find out the difference of all the numbers against the mean. How different are the numbers against the mean? So we got mean as was 8, right? Now what we're doing is find out the difference of mean against each number. Meaning,
How far it is from?
I'm sorry?
How far it is from the mean?
Yeah, the difference basically. This was my mean. First number minus mean. Okay? Do that, do a square of that. Second number versus the mean, the difference of it, square of it. Third number against the mean, square of it. Fourth number against the mean, square of it. Plus fifth number against the mean, square of it. Okay? This sigma is nothing but, not the sigma male that you guys talk about. This sigma is nothing but sum of the difference of the squares. That's what this means. Okay? Everybody okay? Riya, Sahil, Arush, everybody okay, right? Ritika, Vishal, everybody? Yeah, okay. Ananya, okay with that? Alright. So here, this sigma, not the sigma male, it represents the sum of something that we are trying to do. Okay? That's the symbol that is used in math. When you are talking about sigma, that's what it is. Okay? So this sigma is representing the sum of the difference of the squares of all the numbers against the mean. So you have decoded half of this thing so far. Okay? Let's do it. What did you get? I'll probably skim through this quickly. 1 minus 8 is 7, minus 7, minus 7 square is 49. 3 minus 8 is 5, minus 5, square is 25. 7 minus 8 is 1, minus 1, square of that is 1. 14 minus 8 is 6, square of that is 36. 15 minus 8 is 7, square of that is 49. I'm just adding them up. That is what will give me this part. 14 plus 29 is 73. 74, 75. Why I'm trying to act smart? Let me do it in simple way. 9 plus 6, 15, plus 5, 20, 29. 2 carry forward, 2 plus 4, 6, 3, 9, 11, 4, plus 4, 50, 1, 1, 1. This is my value. Okay? Now, we got the value of this part. Sigma of the difference, square of the difference. And then divide that by how many terms you had in the data set that you look at, 5. And then a square root of that. This is what this whole formula says. Okay? Is everybody with me or I'm rushing through it? Yes, Smita, operator? Yes, Nandati, Smita, Neil, Sarah, Judy, right? Ritika, fine? Okay, so just to give you guys the rundown of the story, we had these two sets of numbers and we were trying to find out the standard deviation. Standard deviation says this formula, which you don't have to remember or memorize. Basic thing is find out the mean of the number or the data set that you're looking at, and then find out the difference of the mean against each of the numbers and do a square of that. Once you have done a square of all that, which you got as 159, divide that by how many data elements you had, and 159 by 5 is 150. Let me not do the square root right now. 159 by 5 gives me 30, almost 32. Is square root of that. That's what you have to do. So find out the mean and compare the difference. Whether you're doing mean minus the number or number minus the mean doesn't matter. It will remain the same because you're anyways doing the square of that. Okay? So whichever way you remember, that's fine. Find out the mean, find the difference of each number against the mean, do a square of that and sum them up. Once you have summed it up, then divide it by number of terms you had in the data set and then do a square root of that. Now square root of 32, it will be square root of 36 gives me 6, 32, 5 gives me 25, so it will let me make it up, saying maybe 5.5. This is my standard deviation that we got for this set. This is 5.5. Are you guys okay so far? Everybody okay? Okay. Now we'll do the same thing. See again, the objective is not to memorize the formula and then find out the value. Objective is to understand what exactly the standard deviation means and how does it make us or help us derive some interpretation from that. So here, from this one, with whatever juggling I was doing, we found standard deviation is 5.5, approximately 5.5. I might not be accurate. Here, look at this guy. Same thing, we'll find out the mean of all this. So how much it is? Let's find the mean. Mean is sum of all the numbers. So 7 plus 3, 10, 14, 23, 25. 2 carry forward. 2 plus 9, 11, plus 4, 15, plus 1, 16. Divided by, again, 5 terms. So this becomes 33. Okay? So this is our mean. Now same thing we'll do. Pick the first number minus the mean square of that. Pick the second number minus the mean square of that. Pick the third number minus the mean square of that. Pick the fourth number minus the mean square of that. Pick the fifth number minus the mean square of that. And whatever you got, you sum it up, this is the sigma part of it, then divide that by how many terms you had. 1, 2, 3, 4, 5. Divide that by 5 and do the square root of that. Oops. Okay? So here, we'll do some rounding just to get to the answer faster. This is 33 minus 2, 31 square. 30 square is 90, 900. 30 square is 339, yeah, 900. This is 31 square. I'll just round it to 1000. Okay. 99 minus 33, that gives me 66. 66 square. 60 square is 3600. 66 square, I'll make it up to 3800, let's say. Okay. 44 minus 33 is 11. 11 square will be 121. 3 minus 33, again 31. 31 square, again I'll round it to 1000. Sum it up, divide that by 5. See how much it is. 1000 plus 3800 is 4900. 5021, 6021. 6021 divided by 5. It's like 1200, approximately 1204 or something. Yeah. So, square root of 1200. 10 times 100. Okay. 1200. See, this was 31, square of 31. So here maybe I'll just make it up. It will be probably a square of 34 or so. Look at this. Now what we have is, we have a very convincing way to tell that here the deviation is less, here the deviation is more. Here the variance between the data is less, here the variance between the data is more, because if you find the standard deviation of this set of data, it's only 5.5. Here if you find the standard deviation of the data, is 34. So there is a huge difference between 5 and 34. That's why you are saying the variance is more, standard deviation is more. Is it relatable? Yeah, makes sense? Now, you guys will think that we always knew how to find out the mean. So we are able to find the average. So from where here my average is only 8, here my average is 33. So why we need to even worry about this? See, the average is not the most scientific method of finding out the central behavior of the data. Because if you are looking at, but before I move on, are you guys with me so far, or there is any element of doubt that I need to knock off? Neil, Sarah, Arush, Sahit, Jana, anybody? Jana, are you clear with that? Yeah? Ritika, Vishwa, everybody? Ishan?
Yes, sir.
Everybody clear? So, what I'm saying is, I am kind of countering my own ideas that I shared with you guys a few days ago probably, in the last class. Then okay, we know mean, median and mode, and that tells us the central behavior of the data. How my data is spread. Is it, no, are you talking about a big average? Is my average somewhere in the middle? Is what is influencing the data kind of thing, right? When we talk about mode or the central behavior of the data. Here, why do we need to even worry about finding out standard deviation, which looks like a very complicated formula? Standard deviation. Now, if I write this formula, this will probably not scare you guys. Yeah, where this guy is just representing the difference between the mean and every number and square of that, and sigma represents sum of all of those differences, meaning sum of the difference of each number against the mean and the square of that. So why do we even need to worry about it? What is the point learning standard deviation, right? So now let's look at certain examples. If I am talking about, let's say, a small set of data, 12, 19 and 14 versus 1, 44, or let's say 33. Okay? If I am relying only on the mean, what will happen here? My mean would be what? 12 plus 14 is 26, plus 19 is 45. 45 divided by 3, it is 15. If I am looking at these two numbers alone, this is 33 plus 134 by 2. This will be my mean, which is 17. Yeah? Okay? Here my mean is 15. Not a huge difference between this data and this data. Yeah? Average of this data set, or an average of this data set. Looks pretty close, 15 and 17. Doesn't bother us much. But then, that is still not telling us the actual behavior or the inside information of what we are dealing with here versus here. Even if the mean looks pretty close to each other, but there is a huge difference in the characteristic of the data set that we are dealing with. Here, the variation among the data elements is very little. Here that variation is huge. If you have to forecast, let's say the fourth number, next element here, you'll say oh, maybe 17, maybe 14, maybe 11. You cannot. 133, if you just go by that method, you'll say 33 into 30, so 32 difference, you'll say okay, probably maybe 65 or maybe 33 into 33 because this is multiple of 33, right? So that will be 900 something. But then, so that is going to even get your mean more complicated, more cumbersome, and this doesn't give you the right behavior. Again, I am talking about two data elements just to fast track the calculation, but the underlying message here is that mean, while it gives the average behavior of the data set that you are looking at, it doesn't give you all the characteristics that you need to know. While the mean looks pretty close to each other, but there is a huge difference in the behavior of the data that we are dealing with. Less variance, more variance. Yeah. If you find out the standard deviation of this guy, that will be way higher than what you will find here. So that's why standard deviation is a scientific tool that not only tells us the average, but it also tells how your data is varying. Because now, if you think about it, standard deviation is a tool or technique that is used extensively in our day-to-day life. Think about electricity bill. See, we consume electricity and then we pay bills for it. But then electricity board, which is dealing with thousands, hundreds of thousands of people, they do their forecasting because they have to pay employees' salary, they have to create infrastructure and all. They have to do a lot of calculation around it. If they just take 2 months data and then extrapolate that might not give them a right picture of it, and they might go grossly wrong, end up becoming bankrupt also. But when they look at standard deviation, they will get a little bit different picture of it, I mean, they obviously they don't deal with 2 months of data and 3 months of data. They will deal with larger chunk of data. But then standard deviation gives them a more realistic view of how my data is varying compared to just looking at the average. Because if you choose, see, the data is all about, data analysis is all about the sampling of data we do, right? So if you pick a sample with extreme values, your whole calculation prediction will go for a toss. But if you are just going with mean, but if you are looking at standard deviation, then you are a little more covered with respect to mathematically forecasting your future numbers that you might come across. Was that a great speech or no? No, it was not a speech. I'm just trying to make sure that you guys are getting the intent behind learning all these techniques. It's just not about, oh, this guy is teaching something, let's learn. No, it's not about that. It's about convincing ourselves that why in the world we need to learn this. What is that it equips us with for being a more qualified, being a more informed person to make our own decisions in the long run. Yeah? Everybody clear? Okay. A moment of silence to digest this before we move on, or we are good? Everybody okay? Okay, good. So now we will move on to the next part. So you should, again, math is also like, I mean, though we are not supposed to tell stories in math, but our brain processes things in a sequential manner. If you have to come to the class, you have to come to the class for the first time. Your brain will processing, okay, I have to make sure that I'm eating lunch at this time, getting ready by this time I'm starting, I'll leave by this time so that I can attend the class at this time. So everything is done in sequence. So likewise, here also we are learning this topic. How we are processing this is, okay, first thing is collecting data. Be it with respect to age of all the kids in the class, be it with respect to how kids have scored in the class, be it with respect to how much you studied to get how much score in different exams. You collect the data, and that data is always raw in nature. So we collect the data, try organizing it so that we can make some head or tail out of it. So we go from unstructured raw data to structured data. Now we have data that we can read, but that is just the way we read. And that is where all the calculation we did, mean, median, mode, standard deviation, these are different tools that we used for making some interpretation from the data. But then that is still collection and calculation. The next step is called representation. That is where whatever data you have cooked up or collected, how do you represent that in a form that everybody can understand it and relate to it and make some meaningful conclusion out of it. Okay? That's what will be part of the representation cycle. That is where we talk about different types of tools and techniques like bar chart, pie chart, histogram, line graph, dot plot, scatter plot, and do very best. We'll see. Okay? So that brings us to the point where we will start talking about representation of data. Anyone in the class who is trying to recall what do we mean by different types of charts or graphs or representation of data? And it's okay to ask, because whoever asks, I'm not a doctor, but I'm here to diagnose any problem relating to mathematical concepts. Okay, I'm not even qualified to be called a doctor. I don't have a PhD degree even. So, but then yeah, we are here to diagnose the problem. So, for that, I mean, my request to you would be that in this class, be fearless when it comes to making mistakes. Many times what happens is somebody asks you a question, you think, oh, if I give a wrong answer, what will people think? The problem is nobody has time to think about us. So let's not worry about it. None of us are superstars. I don't know, you guys might become a superstar, I'm not. So nobody knows me. Why would anybody care about me? I'm okay to make mistakes. I mean, as long as I'm not doing something illegal. Making mistakes is fine. Yeah? Alright. So let's start with, so what we'll do is, I will not teach the concepts. What I will do is, I will first show you guys some real problems and see how do we wrap our head around that one. So I'm just trying to recall. Oops. Okay. So let's do a quick recap of what we know about different charts or graphs. And I'll pick everybody's brain to see how you guys relate to it, okay? And again, go with a very open mind. I'm putting hour of the day, or no? Let's say this is 10 a.m., 12 p.m., 2 p.m., 4 p.m. I've just picked up 4 time windows, okay? And putting the temperature of the classroom or bikini or Frisco, or Ritika will say why you are only considering central time zone, so let's say it's Pacific, okay? Ritika, happy with her? Okay. So in Pacific time zone, we don't get that much temperature. So let's say this is 30, 60, 90. Okay. So at 10 o'clock, the temperature was, let's say, around 45 degrees. 12 p.m., by 12 p.m. it became 75. By 2 p.m. it went up to 85. By 4 p.m. it came down to 65, and by 6 p.m. it came down to, let's say, again 30. What you see on the board is called line graph. And say it with so much confidence, line graph. It's okay. If it's not line graph, let's say if it is histogram, I'll say no, this is not histogram, this is a line graph. That's okay. But never stop yourself from making a statement. Okay? Be confident. Saranya, do you agree with her? This is line graph only? Okay? Ritika, Vishwa, Vishal, everybody okay? Agreeing to this being line graph? Now, I want to hear, okay, let me do one thing. Let me give you guys enough substance to build stories. So this is a line graph. Everybody agrees. Let me put another one. Here, I am representing the scores of a 100 marks test. Okay? In a class of, let's say, some 50 kids. This is 0 to 30 out of 100. This is 30 to 60. 60 to 90, 90 plus. This is 10, this is 20, this is 30. And this one is representing 18, let's say. And this is painting 25. This is, let's say, 50. Okay? Or 14, let's say. And this is good. Okay? So, what you are seeing here is called? One more time, think about it. You are close. Okay, let me do one thing. Let me give you guys food for thought. This is the number of students liking different subjects, okay? This is 10, this is 20, this is 30, this is 40, okay? This is math, this is science, this is arts, this is business, let's say. So, what you're seeing are 3 diagrams or charts or graphs, whatever you call them. This one, everybody unanimously said this is a line graph. You're seeing something here, I don't know what it is called. And you're seeing something here below also. I don't really know yet what is that called. Now, what is this one and what is this one? I want to hear the difference from you guys. And nobody is giving me answer because you guys are doubting yourself. Don't doubt yourself. You guys know more than I do. Yes, Jana. I was about to call your name.
Aren't they both like bar graphs?
Both are bar graphs?
Yeah.
Okay, let me get a second opinion. I'll come back to you asking why. Ritika, Vishal, Praneet,
I'm also gonna say that they're
both are bar graph.
Yeah.
Okay. Sarah, Neil,
Yeah.
both
It's part 2.
both are bar graph. Okay, Praneet. First one is a histogram, second one is a bar graph. Okay. Anybody else? Arush, Sahit. Yes, Jina, tell me.
Actually, I agree with the other person that just talked.
That is Praneet.
Yeah, I agree with him.
You agree with him? Okay, we'll see. So this one is histogram, this one is bar graph. Okay, so let me confirm that yes, that answer was correct. But what is the difference? Both look the same. Something being thin and something being fat doesn't make that difference. There's something else also that we have to consider. Why would I draw a bar graph versus, what is the reason which will base the idea for, will be the base for the idea to pick up this one versus this one? I can put this also, right? Let's say this is math. This is science. Whatever. I can recreate this graph using this one or recreate this one using this one. Yes, Jana.
I'm pretty sure that like the first graph shows like range. Or like the greatest amount to the lowest amount.
Okay, that's one good insight. Okay. Praneet, go ahead.
The histogram shows like change over time or like that.
Right. So as Praneet and Jana said, histogram always talks about a range. Mishika, you are 14 minutes early for your class, beta. You'll get scared. Join after 40 minutes, okay? Yeah?
Yes, sir.
Okay. Alright. So here, this is a line graph, this is a histogram, and this is a bar graph. So first difference between these two is bar graph and histogram look pretty similar, but they are not similar, they are not same. Bar graph is always used when you are talking about any representation, but not a range. Here, see, this was a point blank thing. Math, how many kids? I did not say between how many kids for math and science. I did not pick a range. This was like a specific data point that we were trying to validate against, or the specific criteria for which we wanted to check. Here, you say, okay, 0 to 30 marks obtained by kids is this one. So this one probably consists of kids who got 10 marks also, 20 marks also, 29 marks also, 29.99 also, right? Up to 30. So when we are talking about a range to be represented in a graph-like structure, you use histogram. When you are looking at specific data elements where there could be gaps, you will use bar graph. So where we saw the bar graph the most, I believe each one of you have gone through the COVID phase. My pronunciation goes horrible at times. So all of you have experienced what is COVID, right? I mean, we all have went through the pandemic, almost 2.5, 3 years. And what was very widely used for representing how every state, every country, every county, every city is doing, there was a lot of bar graph that was flashing every day on the internet, saying, okay, COVID cases on the rise in certain places, and you will see bar graph, some bars becoming like this all of a sudden. So many COVID cases a city came across on a given day. So similarly, this line graph also is nothing but keep up the bar, okay? You can repeat the bar graph and you can connect these ones, and that's what translates into line graph. So line graph and bar graph are pretty much same, just that bar graph you show the entire data from bottom to the top, wherein in the line graph you are only picking up the topmost point and then connecting them. This one gives you a view of how the data is spread. This one gives you a view of how the data is changing. Oh, this is going up. Oh, this is going up. Or going down. So here, this relates to the concept of line that we have learned, right? Here, when you see a line graph representing like this, it's okay. There is a gradual growth, slow growth. When you see something like this, oh, this line graph has a very high slope. It's increasing rapidly between two data points, between two intervals, right? So this one relates back to the concepts of basic the coordinate geometry that we have learned. See, okay, how slow or fast things are growing. This is just a raw representation of the data. So this is bar graph, this is line graph, and this is histogram. Histogram and bar graph, if you have to choose between these two, you will use histogram only when you are talking about a range of data to represent, and then the data is more contiguous in nature. If you look at it, 0 to 30, 31 to 60, 61 to 90, 91 to 100. It's a continuous growth, contiguous range that you are trying to validate for. Yeah? Noah, there is a horror story going on right now with the elder kids. You are 9 minutes early for the class, but are dealing with the elder ones. Join after 9 minutes, you'll be fine. Yeah? Otherwise, you'll hear something. Oh, Noah got scared. Alright. So, this is the basic difference. Now, I think this is a starting point. And again, if I teach you guys what is a pie chart, what is a bar graph, what is a histogram for long enough, one thing that will come out very clear is I'm wasting time, which is not the intent. So let me do one thing. Let me show you guys the kind of questions that you'll come across that is more relevant for your grade, and see how do we wrap our head around that one. Praneet, shall I make you cry? No, I'll not. I'll not do that, don't worry. Praneet got the message, because whenever Praneet sees there's a new child in the class, he gets scared of me. So I'll tell you that later, okay? Datta is thinking why this teacher is making kids cry. This is the basic principle that we use, okay? Read, analyze, and then do it. And stands for Nike, which says just do it. So when you have a problem to solve, first you read the problem, then you start thinking how you will do it, and then you go to Nike, which says just do it. So that's the summary of it. I did not take much time because Praneet gets super upset with me. I'm just kidding. Okay, so here's the problem, okay? And we'll apply that concept. We are having a graph 20, 40, 60, 80, 100. This is temperature in degrees Celsius, and this is distance from left edge. Okay, this is distance. I'll just put distance. Once I read the question, then probably it will make more sense. 5, 10, 15, 20, 25, 30, and I might not do a great job when it comes to graphing it. I'll still try my best. This is a graph given to us, okay? So far, not even said a single word about the question. Now let me read the question, which is the first part of solving problem, okay? Reading the question. The question says, the temperature T in degrees Celsius, temperature, this is temperature T in degrees Celsius. Now you're seeing from 0 to 120. The temperature T in degrees Celsius along the circular infrared stove measured d centimeters from the left edge of the circumference and going through the center of the stove is given by the graph. So basically it says, let me read it, okay, this is a cryptic sentence. The temperature T in degrees Celsius along a circular infrared stove, let's say this is circular infrared stove, okay. In the kitchen you would have seen, right? You have stuff like this, yeah. The temperature T in degrees Celsius along the circular infrared stove measured d centimeter from the left edge. So d centimeter from the left edge. So let's say this is the left edge of the stove, okay. And whatever you see here, this is the distance. So what it says, see, look at this. When it is 5 centimeter from the left edge, temperature is probably 30 degrees. When you go to 15 centimeter, 10 centimeter, the temperature is 45 degree or whatever. When you go to 15 centimeter, the temperature is 80 degree. So you went here 80 degree. 20 centimeter, temperature is 120 degree. Okay, and then when you keep moving forward, so maybe there are not many stoves, there is only one. Okay, when you keep moving forward, the temperature keeps dipping. So this is your, now visualize this stove being like this. So from the left edge, when you are moving away from left edge, getting close to the stove, the temperature is this much. So here also the temperature is 30 degree, okay, maybe that is the room temperature. And then as you are moving closer and farther from the edge, temperature increases to a certain point. Maybe this is the point where it is maximum, and then again it comes down to this thing. This is what is represented in this one. Are you guys able to follow me what I am doing right now? At least hear the question part. Yeah? Okay. Now it says, so Sanvi G, you have 3 more minutes, okay? Let me complete this question, then we'll talk to the kids from the lower grade. The hottest point occurs at the center of the stove. What is the diameter of the stove in centimeters? So you can even imagine that this is your stove, okay? Imagine this as a stove. It says when you are 5 centimeters, this is temperature, 10 temperature, 20 centimeters some temperature. At 20 centimeter, this is the maximum temperature. So what it says is, the hottest point occurs at the center of the stuff. This is at the center of the stuff, the hottest point. What is the diameter of the stuff in centimeters? What is coming to your mind? All the kids from level 1, hold your horses for 2 more minutes, okay? Don't get scared by what we are doing right now.
Diameter, radius.
Diameter. It says what is the radius, what is the diameter of the stuff? So, okay, we will decode this problem and we'll look at more problems like this in the coming class. Here the whole thing, if you look at it, this says from the left edge, 5 centimeter, this is temperature, 10 centimeter, this is temperature, and says the maximum temperature is the center of the stuff. So basically, if the stuff is from here to here, I mean, this is a circular stuff, right? From 0 distance to the center is the maximum temperature. By looking at this graph, you see, okay, 20 centimeters where is the maximum temperature, and that is the center of the stuff. So basically, if it's circular in nature, we are essentially talking about 20 being the radius. And you have been asked to find out the diameter. You will just multiply that by 2. So here, this problem had no merit in it, but it was made complicated by putting a lot of words around it. Okay, and that is what will be our goal in the coming classes, meaning tomorrow and in the future classes. We will look at these word problems, decode them, because this problem has nothing complicated about it. It's just about how do we read this information, how do we read this data, and then make some meaning out of it. This whole calculation was about 20 into 2. That was the whole calculation. But if it is coming for a SAT exam, it will not ask you, okay, what is 20 into 2? Right? It will try to complicate it. It is in our interest to decode it, simplify it, and then solve it. Yeah? Alright, with that being said, I will let you guys go. I know we did not do much of problems today. We only talked about star deviation and kind of studying that. But now we are getting into the reporting related interesting problems, and we will solve them in the next couple of classes and see how comfortable do we get with those concepts. Yeah? Alright, with that being said, I'll let you guys go. Enjoy the rest of your evening. Talk to you